Question 20 from Section 1 of the 2019 Higher Physics Examination. The output from an AC power supply is connected to an oscilloscope. The trace seen on the oscilloscope screen is shown below. The Y gain setting on the oscilloscope is 1.0 volts per division, and we're asked to find the RMS voltage of the power supply. So right away we have to find what the peak voltage is first of all, because we know from our equations data sheet, we know that VRMS, the root mean supply voltage, is equal to the peak voltage divided by root 2. So our first job is to find that peak voltage, and we do it by looking at the oscilloscope screen, going to the centre line and counting up 3 divisions. So we have 3 divisions upwards to the peak, and we know that each division upwards is 1.0 volts per division. That's what it says, the Y gain. So we know that the peak voltage V peak is going to equal to 3 divisions multiplied by, in this case, 1.0 volts. So the peak voltage is 3 volts. Now the VRMS, the root mean squared voltage, VRMS, will be equal to the peak voltage divided by the square root of 2. So that must mean 3 volts divided by the square root of 2. And if we do that in our calculator, we get the VRMS is equal to 2.1 volts. So our answer will be A. Question 21 from the Section 1 of the 2019 Higher Physics Examination. The output from a signal generator is connected to an oscilloscope. The trace observed on the oscilloscope screen is shown in the diagram below. Now the frequency of the signal from the signal generator is now doubled. The amplitude of the signal is unchanged. The Y gain setting on the oscilloscope is unchanged. The time base setting on the oscilloscope is changed from 1 millisecond per division to 0.5 milliseconds per division. Which of the following diagrams shows the trace that is now observed on the oscilloscope screen? Well, let's go into a simulated online oscilloscope, and it's shown here. Now it's set up to show a sine wave of frequency 250 Hz. And it's got a time base set at 1 millisecond per division. The Y gain is 5 volts per division, which is unchanged, and we also have the input signal unchanged as well. Now the question says we double the frequency, so let's go from 250 Hz to 500 Hz. We're doubling the frequency, and you can see right away we're going to get double the amount of waves shown on the oscilloscope screen. Now, our next move was to keep everything the same, but change the time base and change it so it's half its value. So 1 milliseconds, half of that, I'll have to make that 500 microseconds. That's half of a millisecond. So when I hit that, you can see I'm back to square one. So by doubling the frequency and halving the time base, I don't change the number of waves on the screen. I'll do that again for you. We go and show you 250 Hz, and the time base is set at 1 millisecond. You can see we've got 2 complete waves there. If I double the frequency to 500 Hz, you can see I'm going to have double the waves, but the effect of halving the time base from 1 millisecond to 500 microseconds, that's half of the 1 millisecond, we get the same number of waves as the original. So we go back to our question sheet, we can see that our answer is going to be the same as this diagram here. So 2 complete waves, 2 complete waves. We haven't changed the Y gain or the input signal, so the answer is going to be B.